The other things you're going to run into when you get into this is you're going to see people reference something called blockchain layers. So this is actually really good when you're learning how to think of how a network is actually built. So I kind of want to tie this back to any kind of OSI model. So if you learn the OSI model or you learn the TCP IP model, the blockchain layers is basically the same kind of thing, right? Basically a way of modeling out that network by service types. And it's an easy way to graphically represent what each layer of the network does and then how each one of those layers intercommunicates with each other. So you can break it down to port, protocol, expected behavior, expected communications paths, expected everything between those various layers. Now, blockchain has kind of built its own little 5-layer model to help identify what part of the blockchain performs what function. So think of the OSI model, and now we're going to learn about the blockchain model that's kind of based on that. So the blockchain layers are basically your infrastructure, your data, your network, and your consensus and application. You'll see me reference these as you kind of go through as layer 0, layer 1, and so on. So layer 0 has different properties than layer 1 and so on. So how these layers all work with each other is the interesting part. So if you see layer 0, you're going to have the whole blockchain ecosystem. It's the underlying infrastructure, right? It's the initial stage of the blockchain that allows it to function, such as smart contracts, provide a service, anything else. So this layer provides for a cross-chain communication and interoperability as well. So if you want to tie Ethereum to Bitcoin, that's going to be a layer 0 bridge. So that whole blockchain ecosystem is where it's going to work. And again, we'll go into bridges here in this section as well in just a little bit, because bridges are actually really kind of fascinating in how they work and where they work. If you go into layer 1, that's your infrastructure. That's going to be things like your Ethereum virtual machine, maybe other kinds of virtual machine or containers that run the mining software services, and then messaging between the infrastructure items. So layer 1 is just, again, it's your core infrastructure and how all that process works. Layer 2 is your data layer. That's going to include all your crypto, your digital signatures, your Merkle tree, your hashes, transaction validation through crypto validation. You may also see this called the crypto layer, depending on who's written the model for you. But generally, layer 2 is your data or your crypto layer. You can take it either way. It just all depends on who wrote the model that you're working from and how they chose to approach it. Then the network layer is layer 3. That's your peer-to-peer layer. That includes all your distributed hash table your distributed hash table, peer-to-peer protocols, mapping, survivability, all the rest of it. The DHT is really kind of interesting because that's really an old peer-to-peer technology process. So if you actually go back to BitTorrent, or you go back even to as far back as BearShare and Shareaza, you couldn't keep the entire blockchain or entire peer-to-peer network map in one system, right? It just wouldn't work. So you have a bunch of trusted IPs as part of that digital hash table that will help you find all the other nodes on the network. So you get a seed that will then allow you to find everybody else. So all that's here on the network label. And again, there's some antique technology in here that's really good and really strong and really proven to work with it. Layer 4 is the consensus layer. This is where all the consensus process happens. It can be any consensus mechanism: proof of authority, proof of stake, proof of work, proof of elapsed time. So that's all of the things that go into this whole process on layer 4, that consensus layer. And then finally we get to your application or your presentation layer. This is where your users interact with your application or your smart contract, your exchange interface, your website, your user, anything else that has a user interaction process, including something as simple as building a wallet or signing up for a wallet, can all be at that layer 5. Layer 5 is always where the final layer basically is, always where the user interacts with the system. So essentially that's your 5-layer cake on this one. So these are the core architecture layers that you may hear and you will hear referenced throughout documentation across all of these different kinds of blockchains that you're going to be working with. Think about it like the OSI model or the TCP IP model. Layers help define what function goes where, how they communicate back and forth with each other, and do inter-process communications. So the big thing to pull out of this one, right, is that the generic blockchain is made of 5 generic layers: infrastructure, data, network, consensus, presentation, or application. Some also use layer 0 to represent the whole blockchain ecosystem. So like you're going to bridge two blockchains, it's either going to happen at layer 0 or layer 1. Depends on how they write the bridge. And that's really where we're going to go into this process, just so you have an idea that there's different layers here, and that the layers, again, help you think about and plan in your head and on paper what the blockchain you're building or architecting or engineering or securing is really all about and where it lives. And that's it for this lecture. I will see you in the next one.